All right. I welcome you all to today's class. Please, if you can hear me, please leave a reaction. That's very nice. So in today's class, we are going to continue from where we stopped yesterday or last time. So we did something about fundamental quantities. So today, we are going to continue with what you call the derived quantity. Now, the essence of today's class is for you to understand physics very well, because in physics, we have something that we call quantity. And this quantity just simply means scientific parameters. So scientific parameters just simply means anything that can be measured. So we talked about it last time. So under what we call quantity, under quantity, we have generally, it just simply means scientific parameters that can be measured. So those parameters that can be measured is what we call quantity. That is exactly what we call quantity. So in quantity now, remember that anytime you mention the word quantity, two things are involved. I said last time that it has to involve what we call number and SI units. So we have numerical value, that is, we must have a numerical value, and we must have what we call the SI unit. The essence of the SI unit is to tell you the quantity that has it. So that SI unit will exactly tell you or make you know the quantity that has it. So whether this one is the number. And remember that anything that can be measured must include two things, number and SI unit. It is true that some quantity doesn't have what we call SI units, but most of them do. So under this quantity, we say that we have two types. First of all, we have what we call the fundamental quantities. So we have what we call the fundamental quantities. If you do not call them fundamental quantities, you can also call them what you call base quantity. So it is either you call it fundamental quantity or you call it what you call the base quantity. Then we also have what we call the derived quantities. So the derived quantities can be called derived quantities. Remember that for fundamental quantities, they are called the base quantities because they are not obtained. You cannot obtain them from any other quantity. And they are 7 in number. These quantities are 7 in number. So they are 7 in number. And the last video or the last class that we had, we mentioned the 7 quantities that we have. So before I proceed, I'll still recap or I'll still refresh your memory about the 7 quantities that we have. And the 7 quantities are, first of all, we have the first one, we have what we call the mass. We have mass. Number 2, we have length. These are called fundamental quantities, remember. 3, we have time. 4, we have electric currents. We have electric currents. Let me call it current because of space. All right, 5 is what you call temperature. Temperature. 6 is what we call amount of substance. 6 amount of substance amount. 7 is luminous intensity. So 7 is luminous intensity. Luminous intensity. These are the fundamental quantities that we have. Then for these fundamental quantities, in the last video, we mentioned their units. So this unit is what we normally use to identify them. This one is kilogram. This is meter. This is seconds. Second can be written as sec or as s. But basically, we always write it as second or as s. Then the current has a unit of what? Ampere. Then temperature has Kelvin, amount of substance has mole, MOL, and luminous intensity has CD, known as candela. Remember, these are the short forms, or yes, the short form of representing their SI units. You know the full meaning already. Then I also mentioned what we call the dimension. I also mentioned what we call the dimension. So now, any unit that has kilogram, so any unit that has kilogram, any that has kilogram, the dimension is going to be what? Capital M. So any unit that has meter, or that ends with meter, the dimension is going to be what? Capital L. Please pay attention to all this thing that I'm saying, because by the time we start our derived quantities, we are going to be combining all these things together, because in derived quantity, it's just a combination of fundamental quantities. And when you combine fundamental quantities to get your derived quantity, automatically the unit you are going to get is going to be a basic unit. That is a combination of the units of the fundamental quantities. That is exactly what you're going to have. So pay attention to this that I'm saying very well. So now the dimension of time is going to be what? Now, capital T. Then the dimension of currents is going to be what? Capital I. The dimension of Kelvin is going to be what? Theta. Then theta. Then the dimension of amount is what? N. And the dimension of its candela is what? Capital J. Before I go over to derived quantities, I need to tell you one secret, or something that you would never find in your textbook. Nobody's going to tell you this. So, but I need to warn you about it now. Now, please take note of one thing. The essence of this class basically is because of dimension. I need you to understand how to write dimension, because I discovered that the last exercise or quiz that I gave, so many of you were making mistakes in dimension. So, but this time around, this class is going to clarify everything about dimension. So now what we are going to take note of is this. For dimension, dimension has a pattern of being written, being written. The way we write it, it has a pattern. Now, what is the pattern now? The pattern is M, L, T, I. That is I. What again do I have here? I. We have theta, N, and J. You may say, how do I mean by all these things that I said? Assuming you have, maybe in your quantity, it has M, capital M, it has capital L, it has capital T, it has capital I. You don't write capital I first, followed by T, by L. You just do not rearrange this way. But the pattern is, this is the pattern. Please take note of, this is the pattern. All right. So this is the pattern. The pattern follows that if there is M, write M first. So this is wrong. If there's M, write M first. Then if it is L, write L. Then if T, write T. Then comes followed by what? I, and theta, N, and what? J. Okay, let me explain. Before I go over to derived quantity, let me show you how I mean by that now. Look at example 3. Look at this example 3. Look at this example 3. Under this example 3, you will see the dimension of density written as what? M first before they write L. Do you understand now? I hope you guys are following. Please, if you understand what I'm saying, please leave a thumbs up. All right. So now, if you look at this now, you see they wrote M before what? L. They wrote your M before your what? Before your M. And likewise, let's go back to this. We have, look at this one. For speed, we have dimension of L and T. You see, they wrote L before T. M was not included because M is not in this. Like, this dimension doesn't start from capital M. And because it doesn't start from capital M, what we normally do is, like, it started from what we call L. So it started from L. So we have L and T. You see the pattern, L, T, and so on. So if you look at this now, we can proceed to others. Let me show you something. Okay, look at this one. Look at the dimension of force. So you see the way they wrote it. It started from where? MLT. Look at the pattern, MLT. It also follows that pattern. Okay, let's go down. Let me show you something different. Let's see if you can see something different. Okay, look at this one. Look at a potential difference. Look at number 14, the potential difference. For potential difference, what do we have here now? We have M, L, T, and what? I. Look at the pattern. I hope you now understand the pattern. I hope the pattern is not clear to everyone. If it is clear, okay, the pattern is not clear. If the pattern is not clear, please drop your question in the chat box. If you have question, drop it at the chat box. I will attend to that. So the pattern of writing dimension is you write capital M first if there is capital M, followed by capital L if there is L, followed by T if there is T, followed by I, followed by theta, followed by N, and followed by what? J. So in a situation whereby your dimension has capital N and capital J, which of them comes first? Is it J or before N or N before J? You write your capital N first before your J. That is what I'm trying to make you understand. And that is exactly what I mean by the pattern that it follows. So take note of the pattern. It is always M, L, M first if there is M, L if there's L, T if there is T, I. But remember that in absence of any maybe M or any of those alphabets, you can skip it, but just note the pattern. That's all I needed to know. Okay, now, since you understood this pattern of a thing, now let's quickly go over to what you call the derived quantity. For us to talk about the derived quantities, derived quantities is all about a combination of what you call fundamental quantities. So your derived quantities is all about your combination of what? Fundamental quantities. Before I proceed, please, someone said she did not understand. If you did not understand, go to the chat box and drop your question. I can read it from there and also attend to your question so that I will know exactly what your challenge is. By that way, if you cannot drop your question in the chat box, probably at the end of the class, when I turn on the mic, you can ask a question. So just jot down your question. I'll attend to it later. Thank you. Okay, so let's look at these derived quantities. Let's look at the derived quantities. So what are the derived quantities that we have? Okay. So let's look at the derived quantities. For us to talk about the derived quantities, what are the derived quantities that we have here now? From the materials that I have here, the first one is what? Area. The second is what? Volume. The third is what? Density. And this area has a SI unit of what? Meter squared. Then the next one is volume. Volume has SI unit of meter cube. I will show you how it's being gotten. So, but let me just have a run through of all these things. Density has SI unit of what? Kilogram per meter cube, or you can call it kilogram per cubic meter. It is either you call it kilogram per meter cube. It is either you call it kilogram, or have this. It's either you say kilogram per meter cube, or you say kilogram per cubic meter. They are all correct. Okay. Okay, someone said in the question, what is that? That 0 is theta is for Kelvin, like it is for temperature. So that is for theta. So that MLTI, that is not, oh, that thing is theta. That theta is for temperature. Okay, yes. So that's it. I hope it's not clear. Aniche, Chidozie, Chidozie. I hope it's not clear. Okay. That's about there is. Okay. All right, let's proceed. So let's proceed. We have a master, but there is A there. Which of the A are you talking about? Lovey, please clarify your question so that I'll attend to it. So quickly, so the derived quantities that we have the following is area. We also have a volume. We have density. We have speed or velocity. We have acceleration. Then under acceleration, we have so many of them under this acceleration. We have force. Then we have pressure. Then we have work. Then we have power. We have momentum. We have frequency, acceleration, electric charge, potential difference, and so on. So now this I have here is just kind of a run through of all of them. Now the way I designed this material or the way I wrote out this material is this. I classified parameters or quantities that has the same SI units into one category. So when I'll be mentioning or when I'll be talking about this now, you might observe that I can call a quantity and say that the unit is this. Then I can also measure another quantity, different formula, but the same units. So that is exactly what you need to know. And the reason why you find physics difficult is because all these quantities, you don't know about these quantities. You don't understand these quantities in particular. So if, okay, so you don't understand these quantities in particular. So quickly, let's go back to what you call derived quantities. Now, derived quantities are those quantities, those quantities, those quantities that can or that are obtained. Let me just use the word that are obtained from any other quantity, any other quantities. From any other quantities. So those quantities that are obtained from any other quantities are known as what? Your derived quantities. So it just simply means that you can say that your derived quantities are just a combination of your basic quantities. So when you combine your basic quantities or even combine one derived quantity with another derived quantity, you will now get what you call derived quantity. So, but in terms of derived quantities, they are not among the fundamental quantities. It's all about combination of one or more basic quantity or one or more another derived quantity to get to that. So it's all about combination. So just bear it in mind that in derived quantity, we are having combination. Let's look at the first one. Let me explain how I mean by that now. The first quantity that we have here is what we call area. If you look at this area now, area, first of all, is represented as what? The symbol of area is capital A. And please, when I say symbol, what I mean by symbol, the symbol is when you come to the formula, whenever you see it in formula, area is written as what? Capital A. But if you see small a, it means what? Acceleration, not area. So if you see capital A, it just simply means what? It means area. So that is exactly what I mean by that. So you see the symbol as capital A. And for this now, let's look at the formula for area. The formula for area is what? Length times width or length times breadth. Anyone that you want to call it, they are the same thing. length times breadth. Either way, they are the same thing. Length times width or length times breadth. And what is the SI unit of length? If you go back to our basic units or our fundamental quantities, you will discover that under our fundamental quantities, I said that length is measured in what? Meter. The SI unit of length is meter. And since the SI unit of length is meter, the SI unit for breadth is what? Is also meter. How did I know? Because there are what we call 4 forms of length. There's what we call forms of length or types of length or classes of length. There is what I normally call these forms of length or types of length. Now, the forms of length or types of length that we have are: one, we have actually what we call the length. We also have what we call the length actually. That word length, which is L, just simply means how long something is. How long something is called length. Then aside this one, there's another form of length that we call width or breadth. Width or breadth. This one simply means how short something is. This simply means how short something is. Then we also have another form of length that we call height. Height simply means what represented as h, small h. This one simply means what how high something is. How high. Then another form is what we call distance. Distance. Another one is what we call distance, represented as s. We represent that as s. That one is what is called how far. How far something. So when you hear the word how far, it is called, when you hear the word how far, it is called what? It is called it's known as your what? As your distance. I hope you guys can see what I'm writing. I hope you guys can still hear me clearly. I hope you guys can still see my screen. Please, if you cannot see my screen, please, if you cannot see what I'm writing, please leave the meeting and join back so that you can see probably your network is glitching or you're having network glitch. Okay, so let's proceed. So these are the forms of length. And please take note of one thing. What actually do we call length? Length is anything that has probably a starting point and ending point. It must have a beginning point and an ending point. It just simply means anything that has 2 points apart. It has 2 points apart. Anything that has 2 points apart. Look at this length. How long? Something that is long, it must have a starting point and it must have an ending point. Look at this width. Something short, it must have a starting point and it must have an ending point. Look at this height. How high? It must have a starting point and it must have an ending point. And this time, the same thing, starting point and ending point. So because of this reason, any form of length, all forms of length are measured in what? Are measured in meter. That is why length is measured in meter and also breadth is also measured in meter. So take notes, every one of you should take notes that length, any form of length, all forms of length are all measured in meter. And what are the forms of length that we have now? This length, which is how long, is measured in meter. This width, which is how short something is measured in meter. This height, which is how high something is measured in meter. And this distance, which is how far, is also measured in what? In meter. So in generally, length is anything that has what? 2 points apart. They all generally have what we call 2 points apart or space apart. Like they have space apart, 2 points apart, which is a starting point and an ending point. So if you are going for how long, it becomes length. How short, it becomes width. How high, it becomes height. And how far, it becomes what? It becomes distance. I hope this is clear. If this is clear, leave a thumbs up, please. All right, so now let's proceed to the next one now. Since I've talked about our area, so we have that our area is given as what? Length times width or length times breadth. And since we have that now, length is measured in what? We agree that length is measured in meter and breadth is also measured in meter. So meter times meter will give me what you call meter squared. It will give me what you call meter squared because this has power 1. This one has power 1. Meter, I will choose one of the meter and I'll add the power to give me squared. Remember your laws of indices to give me squared. So that is exactly what we have here now. Okay. Now the next one that we're going to consider is what we call volume. I'm going to be taking my time to explain this thing gradually. I'm not going to rush this. So we're going to learn this thing very, very well. Okay. So now let's look at the next one. The next one that we have here is what we call volume. Let's look at number 2. Our number 2 is what we call volume. Volume. So for volume, volume is represented by what we call, is represented by the letter what? Letter V. It is represented by letter what? Letter V. So that is what we have here. Remember I told you that this letter that we have here, for this quantity, you will see this letter in your formula, not in your unit. This is seen in the formula for this quantity of a thing. Okay, so the formula for volume is what? Is what? Length times width times height. Or you can say that the formula is what? Area times height. So volume has two formulas. You can have this as a formula. The first formula can be length times width times height. Another formula can be what? Area times height. Please, this is not the only formula for volume. If you go over to your mathematics, they can tell you other formulas for volume. But for this here, we are going to just pick this to explain or to derive our units. So that is exactly what we're doing here. Now, since we have it as length times width times height, what is the SI unit of length? Remember, the SI unit of length is what? Meter, times the SI unit of width is what? Meter, is meter. The SI unit of height is what? Is another meter. And since they are all meter, meter times meter will give me what? Will give me cubic meter or meter cube. It's either I call it cubic meter or I call it meter cube. So they are all correct. So I hope you know how I got this meter cube. I hope you know how I got the meter cube. If you know how I got this meter cube, very simple. How did I get this meter cube? Now, this is what I did. Remember that this meter has invisible power of 1. Meter has invisible power of 1. Meter has invisible power of 1. According to your law of indices, you have meter, meter, meter. I will choose one of the m and I'll add the powers to give me what? To give me cube. So that is how I got that cube. Okay, if I do not use this formula, I can also use this formula. Look at this formula. Look at this formula. If you look at this formula, you discover that this formula is a combination of a derived quantity and a basic unit. Sorry, a derived quantity and a basic quantity. Please let me explain. That's what I'm trying to explain to you, what you call the meaning of derived quantity. Look at this formula that we have here. Look at this formula that we have here. This formula is a combination of what we call basic quantity only. Length is a basic quantity. Width is a basic quantity. Height is a basic quantity or fundamental quantity. But coming to this second formula of volume, area is a derived quantity. Remember that we mentioned it here as the first thing. That's the first thing that we mentioned. Area is a derived quantity, whereas height is a what? A basic or fundamental quantity. How did I know that height is a fundamental or basic quantity? Because height belongs to the family of what? Length. Remember the forms of length that I mentioned initially, which are 4 in number. Height belongs to the family of length. So you see that this formula for length is a combination of derived quantity and fundamental quantity. But let's go back to this now. What is the SI unit of area? Remember, the SI unit of area, we measured it initially. The SI unit of area is what? Is meter squared. Meter squared. So the SI unit of meter is what? Meter squared or square meter. Look at where I have it on top of this place. Look at it on top of this place. I have it as square meter, or you call it meter squared. Meter squared. D must be there. Meter squared. So area is meter squared times, let me put down this here. I have area is meter squared times height is what? The SI unit of height is what? Is meter. So if you combine this, what is going to be what are we going to have as the outcome? The outcome is going to be, well, remember that this has invisible one. I'll pick one of the meters. I'll pick one of the meters. I'll pick one of the M. Then what next am I going to do? I'm going to say, I'm going to put it as what? 3. Someone asks about the dimension. I'll still come back to the dimension of all these things. I'll still come back to the dimension. The reason why I'm not talking about the dimension is I want you people to understand how these units are being gotten or derived. So that is why I'm here to explain that now. Someone, if you do not understand, if you have something that is confusing, please drop it at the chat box. I'll attend to it immediately. If you have something that you do not understand, drop your comment in the chat box. So for the dimension, we'll still come back to this dimension quickly. But so let's understand this first of all, before we'll now come back to this dimension of a thing. Okay, so now the next one I'm going to talk about is the next quantity that we have here is what we call density. The next one is what we call density. Now, what is this density all about? First of all, if you are talking about, I forgot to tell this, I forgot to say something in this class, and which is, I forgot to say something, which is, let me use this one to explain or to say it immediately. Density. Before you can derive either SI units or dimension of any quantity, these are the steps that you need to take. The steps that you need to take is, first of all, state the quantity. You need to tell us the quantity that we're talking about. What quantity are we talking about? Let us know about the quantity. That's the first thing you are going to do. The first formula for V are all fundamental quantity. Yes, that first formula of V are all fundamental quantity. Yes, that is the length, the width, the height. They are all fundamental quantities. Yes, they are. So, but the second formula, which is area times height, the area is derived and height is fundamental quantity. So that's it. So back to what I was saying. For density, sorry, for you to write or for you to get the SI units or dimension of any derived quantities, the steps that you're going to follow is, 1, you are going to start with what you call the quantity, then followed by, after quantity, you have to state the formula, because from the formula, you will now get the SI units. Then after the formula now, you are going to get what you call the SI unit. In fact, you are going to get what you call the basic units, or you're going to, let's call, say, you're not going to get your units, whether basic units or your normal units. So then after that, from your units, you cannot get the dimension. These are the steps that you need to take note of. Now, what are the steps again? For every derived quantity, these are the steps you're going to take. First of all, state the derived quantity that we're talking about. What derived quantity are we talking about? Secondly, mention the formula. What is the formula for the derived quantity? That derived quantity that you talked about, what is the formula for that derived quantity? The third one you're going to talk about is the units. From that formula, you are going to get the derived units. You are going to get a derived unit from the formula. So you're going to obtain what we call a derived unit. And these derived units are always in 2 forms. Normally, you can have your normal unit. You can also have what you call the basic unit. I'll explain the basic unit later. Then finally, if you're going for dimension, you can, from these derived units, get your what? Your dimension. So these are the first step, the 4 steps that we are going to take. But for now, I am focusing on quantity, formula, and derived units. I am yet to mention dimension. Or should I even include the dimension immediately? I think I need to include it immediately to make this class faster so that we won't be going back and forth. Or yes, I'm recording the class. Yes, the class is being recorded. Okay, somebody says steps for what are there? Now, these steps that I listed here is the step of obtaining, if you want to obtain, or steps. These are steps of obtaining derived units and dimension. If you want to get your derived units and dimension, you have to take note of. These are the following things that you have to bear it in mind. You have to bear in mind. So these steps are the steps that you're going to take in obtaining your derived units, the derived units, and also your dimension. So the steps are, first of all, what quantity are we talking about? Secondly, you have to know the formula of that quantity. Third, you now, from that formula, you get the derived units. Then after the derived unit, from the derived units, you can now get the dimension. I hope that is clear. I hope that is clear. If that is clear, please leave a reaction. Okay. So these are the steps that we need to take note of. So let's go over. Since we've already know the formula, the steps now. So let's start from where we stopped. Let's continue for where we stopped. Sorry. Let's continue for where we stopped. So the one we're going to consider now is, let's consider what we want to consider a quantity. So what quantity are we talking about now? Density. Remember the first step. The first step says the quantity first. So what quantity are we talking about now? Density. And remember, density has a symbol. How do we represent density? Density is represented as rho, kind of P, bent P, like P that is like E, but it is not E. That P is like E, but it is actually not E, but it is like P. Okay. Then after stating the quantity, what else did I say you should state now? You are going to state what? The formula. And what is the formula for density? Mass over volume. Remember that M simply means mass. I talked about it in my previous video. The small m in a formula simply means mass. And capital V, we mentioned it now, simply means volume. You remember that. So mass over what? Volume. Now, after stating the formula, remember I told you that the steps are quantity first, which is this one. Second step is what? Formula, which is this one. Then the next thing I'm going to do is what? I am going to obtain my what? My units, which is the third step you're going to take now. So the third step is what? Obtain your units. And what is your units now? Your unit is what now? What is the SI unit of mass? The SI unit of mass is what? Kilogram. Okay, I'll now put my over. And the SI unit of volume is what? Meter cube. Remember, we've talked about it before, that the SI unit of volume is what? Meter cube. So if you now rewrite this in properly, the SI unit will now be like, how would the unit be like? The unit is going to be what now? Kilogram what? Because of this pair, if you now bring this number on top, it now becomes M minus 3. Remember that it was positive. It was positive when it was below. But as soon as I bring it on top, because of this over, as soon as I bring it on top, the positive 3 changes to what? Negative 3. And that is why I have it as minus 3. So how can I call this unit? This unit is mentioned as kilogram. You now call your minus per meter cube, or so I can call it, the name is going to be like kilogram. I can say kilogram. Okay, this minus becomes what? Per. Then this meter becomes what? Meter what? Cube. Or I can also call it what? I can also mention or name it as what? Kilogram. Sorry, I can call it as kilogram per this minus remains per cubic what? Meter, as M is now meter. So you see where I wrote it here, I wrote it as kilogram per cubic meter. They are the same thing. So the way to call this is either you call it kilogram per meter cube or kilogram per what? Cubic what? Meter. They are all the same thing. Are you guys still with me? Are you guys still with me? Please, if you're still with me, all right, okay. I hope these explanations are becoming clear. All right, okay. So this is the SI units. Then remember the fourth step. The fourth step is what? Dimension. I didn't want to talk about dimension now, but it looks like I need to mention it immediately to save our time, because we have a lot to explain. I have a lot to explain. So let me quickly mention this dimension from this density. Others will not be difficult for you guys, though I'll still come back to it in a little bit. So for dimension, if you want to write the dimension, assuming you were asked to write the dimension, how will you write the dimension now? The dimension of this is this now. Let me give you a quick recap of how to write dimension. Okay, so let me give you a quick recap. So dimension basically, before I talk about this now, dimension basically, I can just say that dimension is just an application of your fundamental quantity. So application of your fundamental quantities. So that's your fundamental quantities. Whenever we apply these fundamental quantities, we are talking about your dimension. And what are the fundamental quantities that we have? The fundamental quantities that we have is, remember, we have mass, we have, in fact, you know the pattern already. Just the pattern is M, L, T, I. What again did I say initially? I have it as M, L, T, I. T, I what? We have theta. Theta, we have N, and we also have what? J. So that is it. That is it. So these are the dimensions. Now, I will explain before someone says they are confused. They are confused. Mass, this is mass, this is dimension, this is dimension, this is dimension. The dimension of mass is capital M. The dimension of length is capital L. The dimension of time is what? Capital T. The dimension of current is what? Capital I. The dimension of temperature is what? Theta. The dimension of amount of substance is what? Capital N. And the dimension of luminous intensity, luminous. The dimension of luminous intensity is what? Is capital J. But the problem is, it's not about saying this now. How can you identify, or how can you identify this dimension? Since I say something that the first step that we have is quantity, formula, units, and dimension. It just simply means that for you to get the dimension of any quantity, you need to know the units of that. You need to know the units of that quantity. You need to know the units of that quantity. So it just simply means that for me to identify this now, how will I identify this now? Anything measured in kilogram, just take note of this. Anything measured in kilogram, call it capital M. Anything measured in kilogram, if you see a unit, if you see unit kilogram, the dimension will become what? Capital M. If you see a unit, if you see meter as the unit, the dimension becomes what? Capital M. If you see seconds, units, like these are the units. If you see unit seconds, the dimension becomes what? Capital T. If you see ampere, which is capital A, the units, sorry, if you see the units ampere, the dimension becomes what? I. If you see the units Kelvin, the dimension becomes what? Theta. If you see the units mole, if you see the units mole, the dimension becomes what? Capital N. If you see the units CD, candela, the dimension becomes what? Capital J. So what am I trying to say? What I'm trying to say is this now, that the units will help you to determine the dimension. So units kilogram is what? Units kilogram is what? Capital N. Units meter is what? Capital L. Units second, S simply means seconds. Okay. S simply means what? Seconds. S simply means seconds, which is capital T. A simply means what? Your ampere simply means what? So your ampere has a dimension of I, your Kelvin has a dimension of theta, and your mole has a dimension of what? Capital N. Then candela has a dimension of what? Capital J. I just say that this dimension just simply means application. I can just quickly just say, but nobody asks you that in exam. It's just for your own understanding. It's just an application of your fundamental quantities. And if you look at it now, you see that I'm applying my fundamental quantities. So that's all I need to tell you about it. Application, I wrote it out. You can see what I wrote at the beginning. So because of this now, you discover that if I have, let's give an example. Let me give you an example. If I have my SI unit, assuming I have my SI unit to be meter squared, this is my unit. Remember, this is my unit. And I ask you to write the dimension. The dimension is going to be what now? Capital L squared. Why is this so? Because I said that anything measured in meter must be written as what? Capital L as the dimension. Meter, anything meter must be written as capital L as the dimension. So you see that capital meter is written as the dimension. So for it to get the dimension, always take note that the dimension can easily be gotten from where? From the units. Where did I say that you can get a dimension now? The dimensions are easily gotten from where? From the units. And remember what I told you, where can you get the unit? The unit is gotten from where? From the formula. And the formula, where did I say you can get the formula again? The formula is gotten from where? From the quantity. Remember the steps. The step is what? Quantity, formula, unit, and what? Dimension. What did I say again? The four steps are what? Can somebody give me the 4 steps again in the chat box? Give me the 4 steps. The 4 steps are what? Yes, one is what? Quantity. What again? Quantity. Yes, what again? What again? The second step is what? The second one is what? Unit. Yes. What again? Quantity. Is it quantity unit? No, you are wrong. The first step is what? Quantity, formula, units, and dimension. So the steps are what? Quantity, formula, units, and dimension. So someone should write it properly in the chat box so that others can view it. Someone should write it properly. Write it properly. Start from the beginning. Quantity, formula, units, and dimension. Someone should do that. Okay, let's say Aniche, write it out for us. Just write out the 4 steps for us so that we'll take note of that. Write out the 4 steps for us. Yes, correct. Oh, Sugar has done a lot of nice job. Yes, the formula, it is what? Quantity, formula, units, and what? Dimension. So from the quantity, you mention a quantity. If they mention a quantity, so assuming you come to the exam and you are asked to write the dimension of something, let's say the dimension of speed, for instance. Assuming you're asked to write the dimension of speed. So what are you going to do? First of all, the first step is what? You write the quantity. The quantity is what? Speed. The second thing you're going to do is that you state the formula. The formula is what? Assuming you're still learning, you can skip one of the steps, or you can skip that formula, assuming you've learned very well. But since you're still learning, the first step is what? You call the quantity, which is speed. The second thing you're going to do is you state the formula. The formula will now help you to get the SI units. And from the SI unit, you'll now get the dimension. These are the 4 steps that you need to do. So very simple stuff. Very, very simple. So since you've already understood it now, let me proceed. But before I say something, before I proceed, let me warn you against something. Please, this I'm about to say, don't get confused. Don't get confused. There's something that I'm about to say now. Please don't get confused. And the reason why I want to mention is that most times when you come to your JAMB, you will see a question like that in your JAMB. So I don't want you to get confused over that now. Now, I said that for area, let's say area. Okay, let me not use area. Let's start with volume. Let's say volume. I want you to write the dimension of volume. How can you write the dimension of volume? Remember how we normally do it. What is it now? We start with the quantity. The quantity is volume. And what is the formula for volume? Length times width times height. That's the formula. Then the next thing we're going to do is the SI unit, which is meter times meter times meter, and which is going to give you what now? Meter cube, sorry. It's going to give you meter cube. From this meter cube now, what is going to be the dimension? Can someone give me the dimension? Yes, length times width times height, correct? So can somebody tell me the dimension of volume? The dimension of volume is going to be what now? It's going to be what now? Capital L cube. Remember, why is it L cube? Capital L all cube, because meter is what? L. I said it initially. But there's something I want to make you understand. I need to clarify one thing. In your JAMB, in your jump, you might see something like this. You might see something like M0, L3, T0. You might see something like this. Did you know that these two things are the same thing? It is either you have it as L cube or you have it as M0, L cube, T0. Why are they the same thing? I'm saying this. That is why it's kind of painful that anyone that misses this class, you are missing a lot. Anybody that is missing this class is missing a lot, because the information that I'm saying here or what we are learning here now, if you like, read your textbook from now till next year, you can't see those information. So these are experiences. So now, why did I say both of them are the same thing? M raised to power 0 or anything raised to power 0 according to mass is what? 1. Do you get? I said that anything raised to power 0 is what? 1. So we have it as 1 times L cube times T raised to power 0 is also what? 1. So automatically everything becomes what? L cube. So in your JAMB, most times JAMB, especially JAMB does that. They love that. They can give you something like this. And probably you may not know that this dimension just simply means the dimension of what? Volume. Why? Because L cube has the number alone. It's only half that of what? L cube. L cube is the only thing there. Every other thing there is not useful. So just take note of this that I said. Just bear it in mind. I hope I didn't confuse you. Did I confuse you? I hope this is clear. My explanation, was it clear? Was my explanation very clear? Okay, so my explanation is not clear. So let me explain. Let me explain again. I said that sometimes, let's take an example. Give me an example of what you know. Okay, let me do that with an example like area. We know that area is represented as A, and the dimension of area is L squared. L squared, we have done that before. We have done that before. The dimension of area, let me do that with area. The dimension of area is L squared. Now, coming to your exams like JAMB, instead of JAMB to give you this as L squared as the dimension, they will combine it. How do I mean by they will combine it now? They might combine it with the pattern. Remember the pattern. The pattern is M, L, T. Remember the pattern. M, L, T, I, theta, and so on. Remember the pattern. They might just use the pattern way to ask you the question, the dimension that has this. Now, when they now write this pattern, especially the pattern they normally write is just MLT. They don't go beyond that. If they are to ask you this kind of question, they only write MLT. They don't go beyond that. Now, what they are going to do is this now. They'll now write MLT. They now come to this M. They now write 0, L, 2, and T, 0. Actually, the dimension of area is just L squared, but they just added this M0 and T0 just to confuse you. So I'm trying to make you understand that this T0 and M0 they added extra doesn't mean anything. They are all equal to 1. This T0 is 1. This M0 is just 1. And 1 times L squared is just L squared. And L squared times 1 is also L squared. They are only just putting it there to just get you confused. Okay. My network is bad. I hope you guys can hear me. Can anyone hear me? Is my network breaking? I hope you guys can hear me. Are we still there? Okay. All right. So for those of you that are having network challenges, I think they are going to watch the recording. And this video, I didn't expect this live video to stay long, because when you start watching the recording, you may not like to, in fact, the recording might be boring to you, because 2 hours or 1 hour plus is very, very long. So should we end the class? Should we end the class? Because I don't want this recording or this video to be too long. Or should I continue? Some of you are shouting no, but if you want to watch the recording, it's going to be difficult. That's why I prefer every one of you to be in the live class, because in the live class, you are going to learn a lot. But if you start watching the recording, most times it can be boring. Recording is always boring. That's why I didn't do videos and send. That's why I'm doing live class. I would have done videos and send, but sometimes it's boring to watch videos because I know what it is. So life classes are always better. Okay, now let me continue. So I hope my explanation this explanation that we have here is very clear. So out of the whole thing that they have here, all these things, they are just confusing you. They just have L squared. So that's it. So it's only when you understand all these small things, that's when if you write your JAMB or if you write your work, you can answer it very, very well. All these exams are very simple. Even IGCSE, very simple. All these AP exams, foreign exams, they are very simple, just for you to understand them. Okay, now let me continue with the next one that we have. So we were at dimension, sorry, we were at density before we now digress to dimensions. So let me explain that. Let me talk about that density again. Okay, let's start with the number 3, that density. So if I ask you, can you give me the SI unit of density? Can you give me the dimension of density? I need the dimension of density and I need the density, the SI unit of density. How can we do that? You remember the step. Step 1, what are we talking about? We'll talk about the quantity. What quantity are we talking about? Density. Density. And how do we represent density? I said rho. It's like rho, like rho. Step 2, you talk about that's density. Step 2, you talk about the formula. So what's the formula for density? Rho is equal to what? Mass over volume. Remember, that's the second step. So, and mass, then step 3, from the formula, you're going to derive your SI unit. You're going to get your SI unit. So how do we get that now? We'll say equal to, what is the SI unit of mass? We talked about it as kilogram. And what is the SI unit of volume? We talked about it as what? Meter cube. That's exactly what we mentioned. So for this now, we now agreed that the proper weight, we don't write it this way in the exam. Though some exams, you can write it as kilogram/meter cube, which is kilogram per meter cube. But to write it in a linear form, how do we go about it? Now, sorry for that. Chinenye having a network issue. Sorry for that. Just wait when the recording is out. Take your time and watch. You have today, you have tomorrow to watch the recordings. So thank you. So how do you write this in proper way? Aside this method, how can we write it? You can write it as kilogram dot m minus, this dot is not compulsory. Yes, correct. Aniche got it right. So another way to write is another way to write the write that is what? Kilogram m minus 3. Why is it minus 3? I explained that this m raised to power 3, when it comes up on top of here, the m power 3 becomes what? Negative. So that is why it's going to be called kilogram per meter cube or kilogram per cubic meter. Either way, they are all correct. So we want to get the dimension. The next one is dimension. So what is going to be the dimension? Everybody, can somebody give me the dimension? Yes. Negative. Yes, that is negative. That minus is negative. And that minus is called per. That negative that we saw there. So I said that the m raised to power 3 coming on top becomes negative 3 minus 3. So can someone give me the dimension? Can someone give me the dimension of this? We have gotten, remember I told you that it is very easy to get the dimension of any quantity from its units. It is very simple to get the dimension of any quantity from its units. So what is the dimension here? What is the dimension of this? Okay, ml per meter cube. Okay, correct. That is per meter cube. That's correct. It shows that you guys are following. So how is it? Remember that kilogram is capital M. Yes, kilogram is capital M. Go and check where we said it initially. Then meter is what? Capital L. Then we'll now say minus what? Per cube. Yes, that is the correct answer. Correct. Nice, nice. You guys are following. Nice. This is very nice. I love this. You guys are following. Okay, so let's quickly go over to this now. The next one we're going to talk about is what you call velocity. The next one we're going to talk about is what you call velocity. So the next one is what you call velocity or speed. Both of them, velocity or speed, both of them have the same what? They have the same units. They have the same. If you look at my right up here, if you look at my material, you see that both of them has the same unit as what? Meter per second. So the only difference is the formula, difference in formula. So for the first one, for velocity, the formula is going to remember quantity first, the formula. The formula for this one is going to be displacement over time, while speed is what? Distance over what? Over time. The only difference is just the formula. And both of them has the same, like just the formula in the sense, just the wording. Both of them has the same, like the same thing. Both of them are represented as SS. Displacement or distance are also represented as SS. So that's it. So let's say we choose our velocity, which is S over T. That is the formula. And what did I say initially about, sorry, what did I say initially about distance? What is the SI unit? Remember, we've mentioned quantity. We've mentioned formula. The next one we're going to mention now is the SI units. So let's derive the SI unit. The SI unit of distance is what? Is meter. Remember, why is distance? Why is distance meter? Because distance is one of the forms of length. Remember the forms of length that I mentioned. I hope you guys still remember the forms of length. I hope you guys still remember. Yes, distance alpha. Yes, correct. So we now have distance is what? Meter all over. Time is what? Is seconds. So if you put this in together, we're going to have it as meter per seconds, or you can write it as meter s minus 1. That second can be written as ordinary s. The second can also be written as ordinary s. Everyone knows this. So this is meter per second. Meter per second. So meter per second now, what is going to be the dimension? The dimension is going to be what? The dimension is going to be what? The dimension is going to be what? The dimension is going to be what now? It's going to be capital L, because meter is capital L. Then second is what? Capital what? T, all minus 1. So that is it. So it's going to be what? Capital L, capital L. Somebody said the dimension is going to be M over S. No, the dimension is going to be what? Meter. Remember, meter. This is not capital M means kilogram. Capital M means that the unit is kilogram. So, but if you see small m, which is meter, it is written as capital L. Then for second, it is written as what? Capital T. So that is what we are going to have, minus 1. So it's going to be L T minus 1. Now, what the quantities that have this dimension are? What are the quantities? The quantities that have this dimension are speed, what again? Velocity, and what again? Escape velocity. So these are the quantities that has this dimension. They all have the same units, the same unit of meter per second, meters per second. So for the quantities, the quantities that have quantity that has these are, okay, the quantity that has the unit of meter per second are: 1, we have velocity; 2, we have speed, and I've written the formula for velocity and speed; and 3, we have escape velocity. I didn't include this, so I didn't tell you this one, but let me say it now. Velocity, escape velocity, whereby it is written as a square root 2gm over r. This is the formula for escape velocity. Master, share speed and velocity have their specific direction. When you talk about this now, okay, let me just digress a little bit. Let me digress a little bit and add this in up so that you understand something. Let me start with the first one. Let me start from the first one that I mentioned now. Let's talk about speed. Speed is giving us what now? Distance over time. Speed is a scalar quantity. This is a scalar quantity. It has no direction. Speed of anything has no direction. It is not going towards the north. It is not going towards the west. It's not going towards the east. So it has no direction. It can go anywhere. So it has no direction. So that is speed. That is what you call speed. Then the next one is what you call velocity. Velocity is given as what? Displacement over time. And displacement over time, this one, velocity, has what you call what now? Is a vector quantity. Why do we call it a vector quantity? it has what you call magnitude. That word magnitude just simply means numerical value or size. Please, this is what they call magnitude. Now, let me say something like, if I have something like 2 meters per second, please, this is what they call magnitude. This is what they call magnitude. Because most times, you people hear this word and you think that they are just abstract or big word. So that word magnitude, so this 2 here is called magnitude. That 2 is called magnitude. So this number, numerical value, this number here can be called number, numerical value, or size, or magnitude. I repeat, this number here can be called four parameters, sorry, 4 words, which is, you can call this number here number, you can call it numerical value, you can call it size, you can call it magnitude. This is what we call magnitude. But direction is, so this is what we call direction. When you have something like north, south, east, west, if you hear something like north, west, it is now called direction. So velocity has what we call both number and what direction. So it has that is this is a vector. We are not talking about vector quantity, please. When we still talk about vector quantity, when we come to vector quantities and scalar quantity, I will give you details of that. But for now, just bear it in mind that speed and velocity. Then the last one is what we call escape velocity. Escape velocity. Escape velocity. So for escape velocity, we are going to have the formula as what? Square root what? 2gm all over what? All over r. So you should take note of that. These formulas, you should take note of these formulas. Formula for speed, I've stated that. Formula for velocity, I have stated that. And formula for escape velocity, I have stated that. All of them have the same units. They have the same unit of what? Meter per second. They have the same unit of what? Meter per second. And they have the same dimension of what? LT minus 1. They have the same dimension of what? LT minus 1. So you have now known those of them under the category of LT minus 1, like those of them in that category, or those of them that have the same unit of meter per second. You have not known that. All right. So I hope this is clear. I hope this is clear before we go over to the next one. Okay, let's quickly go over to the family of acceleration. Yes, let's go over to the next category, or the next. Now, the next category we are going to talk about, which is the 5th one, is what we call the acceleration. The family of the acceleration. Acceleration, yes, acceleration, gravitational field strength, or gravitational field intensity. Okay, gravitational field intensity. So acceleration, or those of them under what they call the gravitational what? Field what? Strength or intensity. Those of you in SS3, please take note of this thing, because you're going to see this in your SS3. This is one of the first things you're going to learn in your SS3. Please, can you come back to quantity that have meter per second? Okay, we've talked about those of them with meter per second now. We've mentioned it. Just please, if you are confused, just when you get the recording, watch it again and over again. You understand it. And I will advise every one of you, when the recording is out, even though you understood it, play the recording again so that you understand it. You understand it very, very well. This is one of the reasons why you don't know physics. The reason why you don't know physics is that most times they don't break down these topics or this concept or these parameters into this level. So you just have an idea. And when questions are being asked, you find it difficult. So, but it's only when you understand all these things very well, these quantities are very well, that is when you can solve any question in physics. And until you guys understand this now, I can do more calculations with time. Okay, let's proceed. Okay, for this family, what do you have under this family? For this family, what do you have under this family? Let's start from this family now. They said that those of them under this acceleration, we have the actual one called acceleration. Let's start with the first one called acceleration. The first quantity called acceleration, let's call it acceleration. Acceleration, I told you the format we are using is we state the quantity first. Acceleration is represented as what? A. And A is giving us what? It's either you have it that the formula is going to be V over T, or you can say change in V over T. And this change in V over T is something as V minus U all over T. All these things are the formula. What did I say? All these are the formulas of what? Acceleration. So the formulas of acceleration is what now? V over T, velocity over time. If you proceed further, you might be told that it is the same as change in velocity all over what? All over time. And change in velocity simply means final velocity minus what? Initial velocity all over time. Are you guys still with me? Are you all still with me? Okay. Sorry for that. And he just said she can't see the formula. Is there any of you having the same challenge? Can you all see? Can you all still see my screen? Like, can you see the formula? Okay, okay. So Aniche, okay, Aniche, Chidozie, please, if you cannot see my screen, or if you cannot see the formula, please, you can leave the meeting and join back again so that you will see my screen or see the formula that I'm writing. Okay, so now let's go over to this now. This is for acceleration. The acceleration is giving us V over T for acceleration, and we have it as A is equal to, we are to derive the unit now. You know, we have talked about the quantity, we've talked about the formula. Now we are I should write what? Okay, we can see it. So I've talked about the quantity, I've talked about the formula. The next thing I'm going to talk about is the SI unit. Let us obtain the SI units. I've explained the way I normally get this. Can any of you tell me you remember that this capital V in a formula means velocity. But capital V, okay, sorry, V, not capital V, this is small v, sorry, this is small v. Capital V in a formula means volume, but small v simply means velocity. Small v means velocity. So this is your velocity. And the SI unit for velocity is what? Remember, the SI unit for velocity is what? Meter per second. Meter per second. This is divide. This is division sign. This is divide. So I will say this is for velocity. I will say divided by my time is what? My time is seconds. I'll put it over 1. Seconds over 1. So what am I going to do? I will just say meter over seconds. Remove this division and put multiplication times. Now invert this is going to be what? 1 over what? Seconds. 1 over seconds. If you remove that division sign and impute your multiplication sign, the number here, or what we have here, is going to revert, like it's going to reverse. Okay, time can be written in capital letter. In both time can be written in both capital and small letters, right? No, for time. Please, time is written out. Please, every one of you should take note of this. Take note of this. Time is written in formula. Time is written in small letter. Anytime you see capital T in formula, anytime you see capital T in formula, it means period. It means period. But anytime you see small t means what? Time. Take note of that. Small t means what? Time. I hope it's clear, Sugar. All right. So let's proceed. So, but remember that, but if you see capital T in dimension, you know what it means in dimension already. So you can see it in dimension, whereby it represents your dimension. That one is different. So, but for formula, you should know the difference between both of them. Now, let's go over to this now. If you now continue now, we are trying to obtain our units. Meter times 1 will give me what? Meter. Second times second is going to give me what? What is it going to give me now? Yes, capital V is volume, right? Yes, capital V is volume, whereas small v is velocity. Second times second is going to give me what now? Second squared. It's going to give me second squared. So I can call this now meter per second square, or I can rewrite this in a bring this in on top. It's going to be what? Meter second minus 2. It's going to yes minus 2. That's this place that I wrote second. It can be written at ms minus 2 like this. Yes, they are the same thing. Yes, sec minus 2. Correct. That's it. So that's it. That's what we have. So you now see that this quantity for our acceleration, under our acceleration, we're going to have it as well. meter per second squared, or meter per squared per square meter per square seconds. Even I have it as meter per second per second. Yes, it's also correct. Meter per second per second. That's what I have here. You can call it that, meter per second, but normally what is very common is meter per second squared is the common word that is very, very common everywhere that you see. Okay, so now coming to this now, what are we going to have here now? Since we have gotten this now, what is going to be our dimension? What is going to be our dimension? Someone should drop the dimension in the comments section. Sorry. In the chat box, drop the dimension. First, what's going to be the dimension? Since we have gotten that this is going to be meter per second squared, what is going to be the dimension? Yes, the dimension is going to be what? LT minus what you guys are following. Correct, that's correct. So, but apart from this acceleration has what? What is the unit for? I stated the formula for acceleration as V over T. I also proceeded with what? V minus U all over T. And I also gave you that the unit is what? Meter per second squared. Apart from this acceleration, what else do we have that has the same units? Another thing that we have that has the same unit, look at my material. From my material now, what else do you think that has it now? This G, known as acceleration due to what? Acceleration due to gravity. Acceleration due to gravity, which is the same thing as what? It's going to be what now? V minus U all over what? T. Acceleration due to gravity. You still have the same units as what? Meter per second squared. Then another one that has the same unit is what? Gravitational field strength or gravitational field intensity, G. Gravitational field intensity, G, which is given as gravitational field strength or field intensity, which is given as what? The formula is going to be what? Gravitational force all over what? All over your mass. Gravitational force all over your mass. This capital S, F, means your gravitational force, whereas this M means your what? Your mass. I hope you guys are following. I hope you guys are with me. Nice, nice, nice. Especially those of you in SS3, one of your topic or the first topic you're going to, second topic you're going to meet is this gravitational of a thing. So you need to understand this very well. Those of you in SS3 ought not to miss any of these classes at all. You ought not to miss it at all. So now let's look at it now. I said that this capital F means what? Gravitational force, and this M means what now? Your mass. Remember, gravitational force and mass, like F is called gravitational force, gravitational what? Gravitational force. Then your M means your what? Your mass. Your mass. So, and it still has the same what? Unit. And what unit does it have now? Meter per second what? Squared. So you now see those of them in this category. Yes, meter per second squared. Now, before I go over to the next thing, I observe one thing. Yes, one thing that I observe, and none of you asked me that question, but let me comment on it. Now, did you observe one thing? Look at it, everybody. Did you observe that if you look at this place, look at this gravitational field strength or gravitational field intensity. What did you observe? What is your observation? You observe that it has 2 units. It has 2 units. What are the 2 units that it has? It has 2 units. So for our gravitational strength, which is given as F over M, it has 2 units. The 2 units are, normally that the unit of force is a Newton and the unit of mass is what? Kilogram. Unit of mass is Newton, kilogram. So you can say that the unit is Newton per kilogram. Newton per kilogram, that is, you can say Newton per kilogram. You can say Newton per kilogram. But aside this method again now, this Newton per kilogram, this Newton per kilogram is the same thing as what? It's still the same thing as what now? Meter per second squared. Meter per second squared. It's still the same thing as meter per second squared. I know some of you might not know how it came about. Let me just explain how it came about quickly. Let me explain, because from this explanation, even though I may not be able to explain others, you should know this is exactly what you're going to do. Now, when you come to your exam, can you all hear me? When you come to your exam, And you now write a quantity. This is your quantity. And you now write the formula. This is your formula. You've written your formula. On a normal, you now write the unit. You know that the unit is what? Newton per meter. You now observe that this Newton, capital N, Newton, this Newton is not a basic unit. It's not a basic unit. Yes, gravitational field intensity. This is gravitational intensity. Gravitational field intensity. Yes, it is for gravitational field intensity. Yes, that formula is for gravitational field intensity. You now observe that. Okay. Oh, sorry. Okay, you are correct. Yes, my dear, you're correct. Thank you. Thank you for that correction. Thank you for that. Newton per kilogram. Yes, you're correct. Now you now observe that this Newton is not among your basic units. Remember the basic unit that we have. The basic unit that we have is kilogram, meter, second, ampere, mole, Kelvin, candela. These are our basic units. These are our basic units. You now discover that this Newton is not among these basic units. What would you do? Now, because if you observe that the unit that you have is not among the basic units, you cannot get a dimension. There's no way you can get a dimension. So what you're going to do is you continue to break it down. You continue to break that unit down. You have to break that unit down to get the master is Newton, a derived. Yes, it's a derived unit. Please, any other unit, any unit that you see that I'm writing that is not among this basic unit is a derived unit. Any unit that I called alone. For instance, I mentioned the word Newton alone. I just mentioned the word Newton alone, just Newton. Newton is a derived unit. Why did I say it's a derived unit? It is not among the fundamental unit that we have. I mentioned initially. Or maybe I say something like meter per second squared. Meter per second squared is a derived unit. Why? Because it is not among here. This is a singular unit. It's either basic or fundamental unit that we have sorry, let me explain again. Basic or fundamental unit that we have is either kilogram or meter or seconds or ampere. It must be singular. They must be singular. But when we have a combination of one or two of them, it is now called derived quantity. Or when you have something like Newton that is not among them, it is now called a derived unit. So yes, Newton is a derived unit. So let me proceed. So if you look at this Newton is a derived unit because it is not among our fundamental units. So since it's a derived unit, what will I do? Please, you have to break it down. You continue to break it down. How will you break it down? Remember now, you can now see this unit as a quantity. You can now see it as a quantity, whereby you now give us the formula. Or better still, let me explain it this way. Let me explain it this way. I have it as G is equals to F over M. And I know that F will give me Newton. Yes. Can gravitational field intensity dimension broken to M? Yes, that's what I'm about to do now. I'm about to break it down to show you how we got the meter per second square. That's exactly what I'm about to do. So now this is what we're going to do. So how would they got it is this now. First of all, since I know that force is Newton, and Newton is not among the fundamental quantities or basic units, what I will do is I'll break down this force into further. I'll break it down again. So which is I'll break it into mass times acceleration. Remember that force is mass times acceleration. Mass times acceleration. I will now say divided by mass. Divided by mass. So if you divide it, automatically you now see that your G is the same thing as your A. You now see it. And remember your A is what? What is your A? Your A is the same thing as what? V over T. And you know that this is something as what? Meter per second squared. That's how it is. Is that clear? Okay, sugar. Okay. What's our confusion? What's our confusion? Okay, someone say it's not clear. Lovey say it's not clear. Lovey, where are you confused? Just drop the comment, drop your question. Let me know where you're confused. Where are you confused? Not clear, not clear, not clear. Okay. Let me explain again. Let me go again. I have my G, and the formula for gravitational field intensity is F over what? F over M. And the normal, after this quantity, you write the formula. After the formula, you now write the unit. The unit is what? Newton per kilogram. I don't even know why I keep writing meter. Sorry, Newton per kilogram. Newton per kilogram. That is it. And I discovered that since I have Newton per kilogram, Newton is not a basic unit. And since it's not a basic unit, I cannot get a dimension. It's going to be very, very difficult for me to get the dimension. So what will I do? What I will do is I will cancel this. I will not use this. I'll do something like this. I'll say F is equals to something like this, M. Then I will now continue to break. I'll break down this force down. I'll break down the force down into another formula, which is mass times acceleration. Another formula for this is another formula for force. You can agree with me that another formula for force is what? Mass times acceleration. I keep breaking it down. I keep breaking down the formula. So that's what I will do. I'll say all over what? All over mass. So when you cancel this mass and cancel this mass, I hope this is clear. I hope what I'm doing now is clear. Okay? You now cancel this mass, cancel the. Remember, the reason why I broke down this formula further is because this unit, Newton, is not among the fundamental quantities, fundamental units. So since it's not among the fundamental units, I will break down this force down. I'll continue to break it down. So that is why I now got from force, I now got M times A all over M. So I'll cancel this and cancel this. So if I cancel this now, you now see that my G is something as my what? As my A. And you know, we've talked about acceleration before. And what is the formula for acceleration? You agree with me that the formula for acceleration is V over T. And you know that the SI units for acceleration is what? Meter per second squared. We have done this before. I hope this is now clear. I hope this is now clear. Okay. All right. I intend stopping early. Yes, I don't even want to stay long in this class. Now, since I've explained this and you understood all this now, this is what you're going to do for me now as a task. Your task is, I have more than, and I hope okay, we've written the dimension. The dimension of this one is LOT squared. LOT squared, sorry, LOT minus 2, yes, this is the dimension. So now, this is your task now. Your task now is you continue from question number 6. Question number 6. Sorry, you continue from quantity number 6. Quantity number 6 says force and related quantities. Force and related quantities. And what are the members of force? Those of them that are under force. The unit of force generally is Newton. Generally, it is Newton. But by the time you break it down, I've already done it here. I've done it here. By the time you break down force, you are going to get a kilogram per meter squared. Okay. You're going to get a kilogram per meter squared. Yes, you're going to get kilogram per meter squared. So we have those of them under force. We have, look at those of them under force. We have force. You see the formula for force, weight, frictional force, centripetal force, thrust or tension. Look at them. You should take note of them. Then after that, you study the way they did it. Study the way they did it. Because we're still going to have a conversation. You're still going to tell me whether you understood all these things. Then you go over to pressure. Coming over to pressure, you see that pressure has a general unit of what? SI unit of pressure is what? SI unit of pressure is what? Pascal. It's Pascal. And since it is Pascal now, the basic unit, look at the basic unit. Try to see how they derive or how I got this this basic unit. Though it is written, you see the way the place they wrote derivation, it is written here. You see the way they derived it. So you see it, all these things are under it. We also have work, we have heat, and so on. So take your time, go through all of them, each and every one of them. Please don't leave any. So I hope you guys can study these materials. I hope you can study it. And, you know, from my explanation, from all these things that I did in the video, you can figure them out. I hope you can. I hope you can. All right. So since we can, I think I'm going to call this class a day. I'm going to end this class here. But before I do so, let me see. Do we have anyone? Any question? Do we have any question from anyone? Any question? Let's see. Any question? Any question?